All right, I'm Jackson Ferguson. This is my breadboard for the light sensing robot. This is lab 2. So, quick look, everything is flush on this side and on this side as well. It's plugged in for power. I'm going to explain a little bit about these buttons here. They're connected to the power. The green is connected to the power as well. And these are resistors that are pull down resistors, and they're after the button. This makes it so that these, which are connected to analog ports here, always read at 0. And that is because there's static electricity or things that could fluctuate these analog pins, but those voltages from the static electricity or other interferences would be stopped by those resistors. And each button is configured that same exact way. Over here, we've got the power and the ground being connected to the same spots. This ground and that travel all the way over to the other side. And over here, these resistors are connected to that ground. These are connected to digital ports, and those digital ports send out voltage and current into these LEDs. These LEDs, they get the input, turn it into light, and then move it to these resistors into the ground. Okay, now let's show what this does. So we're going to first be doing driving left, which is this button here, and we are now driving left. Sweet. Next, we are going to be driving right, and there we go, driving right with this button. Now, the middle button is a collision one. I'm going to show you with the left, if we get a collision, it goes back. Collision, goes back. Right, collision, no collision. Okay, collision, no collision. Middle one's a little bit tougher, but if we have going straight is both of these, and you can change between the two. But if we get a collision, boom, they both turn off as they should. Okay, next we're going to be showing the servo going up, which is this left one, and the servo going down, which is this one. Servo going up turns on, servo going down the other way. Okay, now when nothing is happening, this is signaling that there's no light, but if there is the light directly in front and it's not up or down, or both at the same time, we will press both at the same time and none turns on. But if we unclick, that is what happens. But both buttons do not turn either on. Okay. Next, we're going to be showing combination of driving and moving the servos at the same time. So if I'm driving to the left, turn the up servo on and the down servo on. Cool. The right side up and down and middle both at the same time. I show that with this as well, both at the same time. Now, if we have, this one's more tricky, but if we have it going straight, it can go up and down and together. And now if we get ourselves a collision and we're moving and the servos are moving up and down. Okay, left, servos going up, collision. That shows that that middle one there is gone. Oh, this is so difficult. But yeah, collision. And then going to the right, collision, but also with the servo now, going up, straight, Oh, goodness. So now if we're going right, and there's a servo, and there's a collision. And if we're going straight, and there's a servo, and a collision, and the other one, and a collision, and a collision, and we're doing that. Oh, I'm sorry that that was so blurry, but as you can see, the servos do work when there's collisions. It's working as it should. It's a little bit difficult to show every single possibility with it, but that is what's going on. Now, how the coding works, of course, is when okay, so this is the code that I have for the Arduino. Here we have the buttons for the servos and motors and collisions right there defined. We have the LED pins, the digital pins defined. These are the analog ones. Now we go on and we're defining a threshold voltage. When the buttons, pins for the buttons receive a voltage of 2.5 or higher, that's when they are considered on. Now we're defining detection as 1 or 0, collision as well, and these are all the states. These are the states. So stop, 0, 1, 2, 3, and those are for the finite state machines. We have integers defined as well in the very beginning, global variables, and global actions as well. And here we go, we set up the pins now with outputs and inputs. Sweet. Now we're looping, and we have a debug state, turn it to true to debug, and these are the serial prints for the debugging. Now we're to perceptions. This is the robot perceiving things. So if the second button is pressed, which is left, turning left, it means that there's light to the left. So we're going to say that that's yes. But if we're not sensing light to the left, then it's going to be no. And if the button is pushed on the right side, we're going to say that there's light on the right. And if it's not pushed, then it's going to not have light to the right. Next, we have the button is pushed to button 1. That is the servo moving up. So if it's pressed, yes, we're detecting light up. If not, we're not detecting light up. Same thing here for button 5. If the light is down, yes. If light is not down, no. And the collision sensor. If we're sensing a collision from pressing a button, and this is going to be called later. But if there's a collision, yes, there's a collision, or no. But we're going to get pin voltages here. That will help us later. Is button pressed, and that is, we will put in button pins for that, and we'll get voltages so that our button threshold, if it's over a certain thing, will show that it is either true or false, that it's getting pressed. There is a collision boolean here. These are for later stuff, robot planning. So we have two finite state machines that are being called. We have our collision detection and our servo up and down. Here is our collision detection FSM. This is planning. And our switch cases. Case 1 is if there is a collision, and we will set that to drive stop. But if there is no collision, we'll go to state 1, and this is when there's no collision. And we will have the action for collision off. But we will brake, and then the default is 0, going for that. So that is us detecting collisions. But the finite state machine for the steering of the robot, our case 1, is if there is no light detected, and we will have no driving going on. We also have an if statement to change it if we detect light to the left. Then we'll go to state 1. If it's to the right, though, we'll go to state 2. Brake, and then case 1, driving to the left, is our action. But if we're sensing that it's going to the right, then we will change to state 3. And that is driving straight, because we'll have both left and right being pressed. But if we're sensing that there's no light to the left, we'll change back to no driving. Brake, case 2, is driving to the right. And if we sense that there's something to the left, then we're going to be going to state 3, which is going straight. And if there is nothing to the right, we're going to be going back to no driving. And state 3 is if we are going straight, so both LEDs are turned on. But if there's nothing to the left, then we're just going to go back to the right one. And if there's no right, we're going to be going to the left case. And then we brake, and the default is no steering. Now, this finite state machine is for moving the servos. What we're going to do here is the first one, the static one is set to 0, and case 0 is going to be no servo moving. But if we sense that there is light up and that there's no light down, we're going to move to state 1, which is moving the servo up. But if we do the opposite, where there's no light up and there is light down, we're going to go to state 2, which is moving the servo down. So we got the case 1. The action is moving the servo up. If we sense that there is light up and there's also light down, we're going to go to state 0 again. But if there is no light up or no light down, we're also going to be going to there. And this is similar to action 2. If we're in state 2, then the servo is going to be moving down. If we're sensing both up and down, state goes back to 0, no servo movement. And same as if there's no light up or no light down. And then we brake. And we go to, these are for later things, robot action. So, these are for later things. Oh wait, no. If we have a collision, and the case for the collision is off, we will turn off the middle LED, the blue one. But if we sense that there is a collision, we will turn on the third LED. Next actions that we have is robot driving. If it's a drive stop case, then we're going to turn off both the left and the right LEDs, 2 and 4. If it's a left one, we're going to turn on only LED 2 for the left and turn off the one on the right. If it's only to the right, we're going to turn off the left and turn on the right. If it's straight, we're going to turn both of them on. And then this is for the move servo. The cases that we have is servo move stop, which will turn off both LEDs for the servos. If we're moving up, it's going to turn on the LED on the left to go up and turn off the one on the right. And if we're going down, we're going to turn off the one on the left and turn on the one on the right. And that is it. That is the code. It's a lot of stuff. Sorry I had to sit through that. But that is my robot.